There's a chamber beneath Grand Central Terminal in New York that's been sealed since 1913. No official reason, no documentation explaining what it was for, just iron plates bolted over the entrance, and a century of silence. I found a photograph from 1907 showing workers inside that chamber, standing beside valves the size of bank vault doors and pipes thick enough to drive a car through. The caption read, "Hydraulic Pressure Station," but when I searched for any mention of hydraulic systems in Grand Central's official history, I found nothing. Not a single reference, not a footnote, as if those pipes, those valves, that entire subterranean complex had never existed at all. So I started looking at other stations, and the same pattern kept appearing. London's St Pancras has underground channels connecting directly to the Thames, described in official records as drainage, even though the channels slope the wrong direction and contain mechanisms that look nothing like sewage infrastructure. Paris's Gare du Nord sits above a sealed reservoir, larger than most municipal water supplies, built at the same time as the station, and closed off in 1902 with no clear explanation. Antwerp Central rests on foundation vaults so deep that modern engineers who have accessed them still struggle to explain their purpose or how they were constructed with the technology of the 1890s. These stations weren't just architecture built to shelter trains. They were part of something larger, systems buried beneath the platforms, hidden behind walls, sealed under layers of concrete and forgotten. The physical evidence still exists, but the explanations have vanished, replaced by versions of history that never quite account for what's actually there. And once you begin noticing the pattern, something unsettling becomes clear. The buildings are still standing, but the reasons they were built, and the stories that once explained them, are gone. When I looked at the measurements for the architecture itself, the official timeline stopped making sense. These stations were supposedly built between 1850 and 1890, in an era when construction crews worked with hand tools, horses, and basic steam equipment. No electric drills, no motorized cranes, no laser levels or precision cutting machines. And yet, the buildings they produced aren't just large, they're mathematically perfect in ways that shouldn't be possible with that kind of technology. Take St Pancras Station in London. The main train shed, completed in 1868, spans 240 feet in a single iron arch without a single supporting column beneath it. The official story credits Victorian engineering, but when you actually look at the structure, something feels off. The curve of the arch follows a precise mathematical profile, where every rib distributes weight, with tolerances measured in fractions of an inch. Modern engineers studying it admit they're not entirely sure how it was calculated without computer modeling. The load is balanced so precisely that shifting a single element could compromise the whole structure. Think about that. We can barely achieve this level of precision with modern tools, and they supposedly did it with hand calculations and coal furnaces. And it gets stranger. Official records claim the entire train shed was designed, built, and erected in less than 3 years. That means thousands of custom curved iron pieces, all precisely calculated, were made by hand, transported across London, and lifted into place with rope and pulley systems. Not roughly assembled, but fitted together with remarkable precision. So precisely that it has stood for more than a century and a half without major structural issues. Does that sound like ordinary Victorian construction? Or like they were working from knowledge that didn't belong to that era? Now look at the Gare d'Orsay in Paris, built in 1900. Inside, enormous iron arches stretch across the platforms in patterns that look decorative at first glance, but the layout isn't artistic, it's mathematical. Column spacing, ceiling height, and platform width all follow repeating proportional relationships. The same hidden ratios appear again and again, the kind found in cathedrals, temples, and musical harmonies. This isn't just architecture. Every part of it is arranged according to precise geometric relationships, and the strangest part is how consistent it is. Compare stations in different countries, built by different architects working decades apart. Antwerp Central in Belgium, Grand Central in New York, major stations in Paris, London, and Milan. The same patterns appear over and over. The domes follow the same curves, the platforms follow the same spacing rules. These aren't just similar buildings. They look less like independent designs and more like variations of the same underlying blueprint, as if the architects were working from a shared design language nobody ever officially acknowledged. But the real mystery isn't the architecture above ground, it's what's underneath. Nearly every major station built before 1900 has a large fountain positioned directly in front of the main entrance. Not small decorative pools, but massive water features holding thousands of gallons, fed by dedicated supply lines that required serious engineering. The fountain outside the Gare du Nord in Paris was connected to a pipeline running more than 2 miles from the Seine. The fountain at Milano Centrale drew from an underground cistern larger than many public swimming pools. Cities at the time struggled to provide clean water to residential districts, yet enormous resources were spent building hydraulic systems for train stations. The official explanation is that the fountains were decorative, meant to make stations look impressive. But those fountains weren't isolated. They were connected to infrastructure running beneath the platforms, and that's where the story starts to fall apart. Beneath St. Pancras, there are brick-lined channels nearly 8 feet tall, running parallel to the tracks. They connect to massive valve systems and pressure gates that look nothing like drainage infrastructure. Beneath the Gare de Lyon in Paris, there's a reservoir chamber 40 feet underground, large enough to hold hundreds of thousands of gallons of water, built into the original foundation. Beneath Antwerp Central, there are pump rooms with cast iron mechanisms designed to move water at volumes far beyond what a train station would need for fire protection or sanitation. And these weren't later additions. They were built at the same time as the stations themselves. The architects knew these systems were there and designed the buildings around them. The official explanations don't hold up. Fire prevention gets mentioned constantly, as if Victorian engineers were so terrified of fire that they built reservoirs the size of public baths beneath every platform. But if that were true, why don't other buildings from the same era have anything similar? Drainage is another common excuse, even though many of these channels run uphill or terminate in sealed chambers instead of flowing outward. Cooling systems are sometimes mentioned, even though these water networks existed decades before anyone talked about climate control in public buildings. And none of those explanations answer the real questions. If these were just utilitarian systems, why are they so precisely engineered? Why do the channels follow geometric patterns instead of the shortest routes? Why are the reservoirs placed at depths that mirror the proportions of the buildings above them? Why do so many systems connect directly to rivers through carefully lined tunnels that would have required enormous cost and labor? The deeper you look, the more obvious it becomes. These weren't support systems for train stations. They were the primary systems, and the stations were built around them. A technical drawing from 1872 in the London Archives shows the substructure beneath King's Cross Station. Instead of simple drainage, it depicts a network of interconnected chambers arranged in a radial pattern, all feeding into a central reservoir beneath the platform. The notes in the margins reference pressure differentials, flow rates, and something called hydraulic propulsion sequences. Those two words appear repeatedly, alongside calculations for valve timing and pressure levels. Then the documentation stops. The drawing is stamped, approved for construction, but there are no completion reports, no maintenance records, no follow-up analysis. It's as if the system was built, and then everyone agreed to stop talking about it. The same thing happens in engineering journals. In the 1860s and 1870s, articles discuss hydraulic lifts, atmospheric propulsion, and pressure-assisted rail systems with detailed technical explanations. Then after about 1890, the publications simply stop. Not gradually, not with explanations, just gone. Entire fields of engineering vanish from the record. Newspaper accounts from the 1870s describe train rides as unusually smooth and quiet. Passengers noted how little vibration there was. Stations remained clean despite constant rail traffic. An article from the Times in 1871 described a journey from King's Cross as almost silent, crediting new atmospheric systems that reduced friction. A French engineering journal from 1868 showed diagrams of pressurized air channels assisting train acceleration and reducing coal consumption. These weren't speculative ideas, they were descriptions of working systems, and then they disappear from the record completely. After 1900, references to atmospheric propulsion or hydraulic rail assistance are almost impossible to find. But the photographs tell a different story. Images from the 1860s and 1870s show bright interiors, polished stone, and clean ironwork. No soot stains, no smoke damage, no blackened ceilings. Look at St. Pancras in early photographs. The interior is pristine, even though it was supposedly filled with coal-burning locomotives every day, and the trains themselves barely show exhaust. Small plumes of steam appear in some images, but nothing like the thick black smoke seen in later photographs from the early 1900s. By 1910, everything looks different. The stations are darker. The walls are stained. Workers are photographed scrubbing soot from surfaces that earlier images show as spotless. In less than a generation, these spaces went from bright, quiet, and precisely engineered to dark industrial environments choked with smoke, and no one in the historical record seems to think that transition needs an explanation. Think about that. We're told the Industrial Revolution was a story of continuous improvement, technology getting cleaner, faster, more efficient over time, but the physical evidence suggests the opposite. The earliest stations were quieter, cleaner, and more precisely built than what came later, which leaves only two possibilities. Either our understanding of technological progress is wrong, or something was removed quietly and systematically and replaced with something far less efficient. And if that's true, then the question isn't just how these systems worked. The real question is why they were taken apart in the first place. The transition didn't happen slowly. Between 1890 and 1910, the hydraulic systems beneath major train stations were systematically dismantled. And if you follow the timeline closely, you can see exactly when someone decided those systems had to disappear. In 1902, workers at the Gare du Nord in Paris disconnected the underground reservoir from its supply line to the Seine and sealed the chambers with concrete. The municipal records list structural concerns, but there's no engineering report, no safety analysis, no evidence the system was failing, just an order to seal it, and within months the space was closed. It's still there today, 40 feet below the platforms, intact and inaccessible. At St. Pancras in 1898, crews began filling the underground channels with rubble. The maintenance logs call it an infrastructure update, but never explain what was being updated or why. A photograph from that period shows workers dismantling a massive pressure gate. The metal is clean, intact, not corroded, not damaged. It wasn't broken machinery being replaced, it was functioning equipment being destroyed. King's Cross sealed its hydraulic chambers in 1903. Antwerp Central closed its pump rooms in 1905. Grand Central Terminal in New York, when it opened in 1913, was designed with sealed substructures from the beginning, as if the architects already knew those spaces would need to be hidden before anyone asked what they were for. Across Europe and North America, the same transformation happened within the same 20-year window, and the official explanations are so vague they barely qualify as explanations at all. And while this was happening, something else was being promoted with almost coordinated intensity: coal. Newspapers began celebrating it as the future of civilization. Industrial exhibitions glorified steam engines and coal-fired locomotives as symbols of progress. Schoolbooks framed coal as the engine of modern life. And at the same time, references to hydraulic propulsion, atmospheric systems, and water-powered rail assistance quietly disappeared from the very journals that had discussed them only a few years earlier. The timing is difficult to ignore. As hydraulic infrastructure was dismantled, coal companies were expanding rapidly and gaining political influence. By the early 1900s, mining executives sat on railway boards and transportation committees. Regulations began appearing that required approved combustible fuels, and those fuels were defined almost exclusively as coal. In 1897, the London County Council passed a Rail Standards Act requiring new railway systems to use approved fuel sources, and in the technical appendix, that fuel was defined as coal or coke. Hydraulic systems were reclassified as experimental and prohibited from public use. Within a few years, every railway in London was burning coal. Similar regulations appeared in Paris, Brussels, and New York during the same period. Different cities, different legislators, nearly identical language, all excluding hydraulic alternatives, all mandating coal, all passed while water systems beneath stations were being sealed and dismantled. From an engineering perspective, hydraulic systems were cleaner, quieter, and more efficient. But from a business perspective, they were a problem. You can't monopolize water pressure. You can't create scarcity around gravity. You can't build an empire on a system that doesn't require constant fuel purchases. And that is exactly why it had to disappear. By 1910, the transformation was complete, and the photographs tell the story. Stations that had gleaming interiors in the 1870s were dark and stained. Ironwork that once reflected light was coated in soot. Workers appear in photographs scrubbing walls and ceilings that earlier images never show needing cleaning. The air itself looks heavier, dirtier. These spaces weren't upgraded. They were converted from clean hydraulic machines into smoke-filled industrial halls. But the original systems were never completely removed because they were built into the foundations themselves. The sealed chambers are still beneath St. Pancras. The channels beneath King's Cross still connect to the river, just blocked. The valve assemblies in Antwerp are still bolted to the walls behind locked doors. The mathematical geometry that governs the buildings can't be removed at all because it's part of how the structures stand. In 2003, during renovation work at a major Paris station, construction workers accidentally broke through a sealed wall and discovered one of the original reservoir chambers. The space was pristine, preserved for a century, with valve mechanisms still in place. The discovery was reported, and within days the chamber was resealed with modern concrete and removed from the renovation plans. No public analysis, no technical study, no explanation. That wasn't the 1890s, that was the early 21st century, which means this isn't just forgotten history. It's history that still makes people uncomfortable. The buildings are still standing, the systems are still there, the evidence hasn't vanished. It's just been sealed behind walls, buried under platforms, or dismissed as irrelevant. So here's what we know. In the late 1800s, major train stations were built as integrated hydraulic systems using water pressure and atmospheric mechanics that were cleaner and quieter than what came after. Between 1890 and 1910, those systems were dismantled. Regulations appeared that mandated coal. The technical knowledge vanished from journals and schools, and the spaces where those systems once operated were sealed and forgotten. The story we're taught about the industrial age isn't exactly false. It's just the version that survived after something else was removed. The grand stations weren't the beginning of modern industry. They were the last visible pieces of something older, something cleaner, something that didn't rely on smoke and constant fuel. When that system was taken apart, the buildings were left behind like empty shells, still beautiful, but no longer doing what they were built to do. The chambers are still beneath the platforms, the channels still behind the walls, the geometry still locked into the foundations. Every day, millions of people walk through these stations without realizing they're moving across the remains of a machine that was never meant to survive into the modern world. And the only reason it feels like a mystery is because certain people or certain organizations worked very hard to make sure the full picture was never seen at once.